Our today's topic is sequence and series. From the examination point of view, it is very important for us. First of all, sequence. A sequence is a arrangement of real numbers. Is a arrangement of real numbers in certain order, certain rule or order. Example: 2, 4, 6, 8, and so on. Here each number are increased by 2. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. Similarly, 5, 10, 20, 40, and so on. In similar way, here the number are 2 times of preceding one. The 5 into 2, 10, 10 into 2, 20, 20 into 2, 40. Now, series. If a number of terms of a sequence is connected by an algebraic sign, plus or minus, then it is called series. Here 2, 4, 6, 8, dot is example of sequence. Similarly, the 2 plus 4 plus 6 plus 8 plus is corresponding series of above sequence. Types of sequence. Types of sequence. 1. Arithmetic sequence. A sequence of numbers is said to be arithmetic if the difference between any two successive terms are always same. The example: 10, 12, 14, 16, and so on. Here 12 minus 10 to 14 minus 12 to 16 minus 14 2 के भयो प्रत्येकमा डिफरेन्स हामीले t2 minus t1 t3 minus t2 र t4 minus t3 गर्छौं भने डिफरेन्स सेम आउँछ र त्यो खालको सिक्वेन्स अर्थमेटिक सिक्वेन्स. नाउ another geometric sequence. Geometric sequence. A sequence of non-zero numbers is said to be geometric sequence if the ratio of any term to its preceding term is always same. Example: 5, 10, 20, 40, and so on. Here 10 upon 5, 2. 20 upon 10, 2. 40 upon 20, 2. यहाँ के भयो? अघि नै हाम्रो डिफरेन्स सेम थियो अहिले हाम्रो रेसियो सेम छ. The third, harmonic sequence. A sequence of numbers is said to be harmonic sequence if its reciprocal are arithmetic sequence. Example, 1/7, 1/10, 1/13, 1/16. यसको रेसिप्रोकल हामी हेर्यौं भने एपी मा पाउनु पर्यो. अर्थमेटिक सिक्वेन्सको रेसिप्रोकल हार्मोनिक सिक्वेन्स. इन एपी AP1 general term Tn, it is denoted by Tn, which is equal to A plus n minus 1 times D. Here A is first term, n is number of terms, and D is common difference. The common difference D. This is Tn plus 1 minus Tn. That is T2 minus T1 or T3 minus T2 and so on. Sum Sn n upon 2 2a plus n minus 1 times D or n upon 2 a plus L. When last term L is given, then we use sum is equal to n by 2 a plus L. Similarly, when A and D, the first term and common difference is given, then we use sum Sn is equal to n by 2 2a plus n minus 1 times D. In GP, geometric progression, or GS, geometric sequence, A, general term Tn, which is equal to A into r to the power n minus 1. The B, common ratio R, which is T n plus 1 divided by Tn. That is T2 by T1 or T3 by T2 and so on. The C, sum Sn A times r to the power n minus 1 divided by r minus 1 when r is greater than 1, or A times 1 minus r to the power n upon 1 minus r when r is less than 1. And D, sum Sn is equal to Lr minus A upon r minus 1 when last term L is given. Note, three numbers are in AP, then we take A minus D, A and A plus D. Similarly, three numbers are in GP, then we take A upon R, A and AR. Now mean. Mean 1, arithmetic mean. Number A is called arithmetic mean between A and B if A, capital A and B are in AP. A is called arithmetic mean between A and B, arithmetic mean between A and B if small a, capital A and B are in AP. Then your T2 minus T1 is equal to T3 minus T2 by definition of AP. A minus small a is equal to B minus capital A. This implies A plus A is equal to A plus B. This implies A is equal to twice A is equal to A plus B, that is A is equal to A plus B by 2. Now our formula of arithmetic mean between two numbers is A plus B by 2. Now geometric mean. A number Z is called geometric mean between A and B if A, capital Z, B are in GP. By definition of GP, we have T2 by T1 is equal to T3 by T2. Then G upon A is equal to B upon G. By cross multiplication, G square is equal to AB. Therefore, G is equal to plus minus root over AB. Note, if A and B both are positive, then G is equal to root AB. Similarly, if A and B both are negative, then G is equal to minus root AB. Third, harmonic mean. Harmonic mean. A number H is called harmonic mean. Mean between A and B if A, H, B are in HP. By definition of HP, 1 upon A, 1 upon H and 1 upon B, that is reciprocal, are in AP. Then 1 upon A, 1 upon H, 1 upon B are in AP. By definition of AP, the AP को definition use करता T2 minus T1 is equal to T3 minus T2. This implies 1 upon H minus 1 upon A is equal to 1 upon B minus 1 upon H. तो H ला यता लेम. This is 2 upon H is equal to 1 upon A plus 1 upon B. This implies 2 upon H is equal to LCM AB, the B plus A, that is H is equal to 2AB upon A plus B. Okay, भर्खर हामीले जान्यौं दुईटा नम्बर बीचमा AM अर्थमेटिक मिन, GM ज्योमेट्रिक मिन र HM हार्मोनिक मिन निकाल्ने फर्मुलाहरु. दुईटा नम्बर यदि A र B छ, A र B दुईवटा नम्बर छ, त मलाई त्यस बीचको अर्थमेटिक मिन निकाल्न पर्यो. AM को फर्मुला A plus B by 2 geometric mean GM root AB and harmonic mean 2AB upon A plus B. It is very important for examination. Now we have very important theorem. The AM arithmetic mean, GM geometric mean and HM harmonic mean between any two unequal positive numbers satisfy the following relations. GM square is equal to AM into HM. Second, AM is greater than GM and greater than HM. The proof. Let A and B be two unequal numbers. Then AM arithmetic mean between A and B by formula A plus B by 2. Geometric mean GM is root over AB and HM harmonic mean 2AB upon A plus B. फर्मुला बाट AM को हामीले युज गर्यौं अघि भर्खर बनाएको फर्मुला A plus B by 2. ज्योमेट्रिक मिन यहाँ दुईवटा पोजिटिभ नम्बर छ थ्योरममा, सो मैले पोजिटिभ स्क्वायर रुट लिए रुट AB and harmonic mean 2AB upon A plus B. Now prove first part. A. Here the right hand side AM into HM into HM is equal to, we have AM A plus B by 2 and HM the 2AB upon A plus B. Here A plus B cancel and 2 cancel, which is just AB, and this is root over AB square and this is GM square. So GM square is equal to AM into HM, hence proved. Now proof of second part. B. AM is greater than GM greater than HM. यहाँ AM GM भन्दा ठुलो र GM HM भन्दा ठुलो देखाउनु छ। दुईवटा क्वान्टिटीमा ग्रेटर देखाउनु छ। सो त्यसको लागि we have AM minus GM. We have AM A plus B by 2 minus GM root AB, which is equal to 2 is LCM A plus B minus 2 root AB, which is equal to root A square minus 2 root A into root B plus root B square divided by 2, which is root A minus root B whole square divided by 2. Here A and B are different. Either A is greater than B or B is greater than A, but both are different. So A minus B whole square is always positive, which is positive quantity, non-negative. This implies AM is greater than GM, relation I. Here AM minus GM is greater than 0, किनकि यहाँ A र B दुईटा डिफरेंट नम्बर हो, A ठुलो B ठुलो जुन पनि हुन सक्छ, तर स्क्वायर भइसके पछाडी त्यो नन नेगेटिभ भयो। भनेपछि AM minus GM is greater than 0, that is AM is greater than GM. GM minus HM. We have GM root AB minus HM 2AB upon A plus B. Here root AB is common. So this is root AB times 1 minus 2 times of root AB upon A plus B, which is equal to root AB times A plus B minus 2 root AB divided by A plus B. This is root AB and this is root A minus root B whole square divided by A plus B, which is again greater than 0. That is, GM is greater than HM relation II. From I and II, AM is greater than GM is greater than HM. Hence proved. Okay, we have one example. If G is the geometric mean between A and B, then so that 1 upon G square minus A square plus 1 upon G square minus B square is equal to 1 upon G square. The solution, by given G is the geometric mean between A and B. Here G is the geometric mean between A and B. Then G is equal to root AB or G square is equal to AB. Same. Now left hand side, 1 upon G square minus A square plus 1 upon G square minus B square. 1 upon, we have G square is AB. AB minus A square plus 1 upon AB minus B square. This is 1 upon, here A is common, the B minus A plus similarly in second term the B is common, then A minus B. Okay, continue. This is 1 upon A times B minus A. Here B minus A minus B. So here minus A upon 1 upon B times B minus A. के गरें B minus A र A minus B उस्तै खालको फ्याक्टर छ, मात्र यसलाई इन्टरचेन्ज गर्यो। त्यसकारण यो A minus B लाई B minus A लेखेकोले यसलाई पनि नेगेटिभ गर्यो। Now taking LCM, B minus A same, A and B remaining, and this is B minus A. So B minus A cancel, 1 upon AB, which is AB is G square, and this is 1 upon G square, which is right hand side proved. Okay, we have another example. If A be the arithmetic mean and H be the harmonic mean between two numbers A and B, so that small a minus capital A upon small a minus capital H into small b minus capital A upon small b minus capital H is equal to A upon H. The solution, here A be the arithmetic mean and H be the harmonic mean between two numbers A and B. The formula use गरौँ. Here A be the arithmetic mean and H be the harmonic mean. between two numbers A and B. Then A is equal to A plus B by 2 and H is equal to 2AB upon A plus B. Now the left hand side, our left hand side is A minus capital A upon A minus H into B minus capital A, B minus H. This is A minus capital A. We have A is equal to A plus B by 2 upon A minus H. H is 2AB upon A plus B into B minus capital A plus B by 2 B minus H. This is 2AB upon A plus B. Continue. This is 2 is LCM. 2A minus A minus B. Similarly, in denominator, A square plus AB minus 2AB upon A plus B. 2B minus A minus B divided by 2. AB plus B square minus 2AB upon A plus B. This is equal to here 2A minus A, just A minus B divided by 2. Similarly, A square minus AB, AB minus 2AB minus AB divided by A plus B into the 2B minus B, the B minus A divided by 2, B square minus AB minus 2AB minus AB upon A plus B. A minus B by 2 into A plus B upon, here A is common, A minus B. Similarly, here B minus A divided by 2 and A plus B upon B is common, then B minus A. B minus A cancel, A minus B cancel. And this is A plus B into A plus B upon 2A into 2B. The A plus B by 2 into A plus B by 2AB. A plus B by 2 into A plus B by 2AB. This is A plus B by 2, 2AB upon A plus B. Finally, this is capital A and this is H. This is right hand side. Proved. Okay, we have another example. If A, B, C be in AP, B, C, D in GP, and C, D, E in HP, to prove that A, C, E are in GP. For this, we have solution. A, B, C be in AP, given here A, B, C be in AP. Therefore, the B is equal to A plus C by 2 equation I. The AP means middle term is sum of first and third divided by 2. Similarly, B, C, D be in GP. Therefore, the middle term C is equal to root over BD. That is C square is equal to BD. Squaring on both sides गर्यो rotative यतापटि square आएको छ. Similarly, CDE being HP. Therefore, the D is equal to 2C divided by C plus E. The first मा के थियो ABC being AP. So middle term B is sum of first and third divided by 2. If BCD being GP, then square of second term is equal to product of first and third. Similarly, if CDE being HP, then second term is equal to 2 times of product of first and third divided by sum of first and third by formula. Now we need to show that ACE are in GP. We have to prove that ACE are in GP. That is GP. ACE are in GP. त्यो गर्नलाई बीचको टर्मको स्क्वायर C square is equal to product of first and third A. यो चाहिँ हामीले देखाउन सक्नुपर्छ. त्यसको लागि okay, for this from equation II we have C square is equal to BD or C square is equal to B. We have B is equal to A plus C by 2. B A plus C by 2 into and D. Here D is equal to 2C upon C plus E. 2C upon C plus E. Using equation I and triple I. Here 2 to cancel or C square times C plus E is equal to C times A plus C. Here C is again cancel, then C times C plus E is equal to E times A plus C, or C square plus C is equal to A plus C or EC. The C, EC both are same, to cancel, then that is C square is equal to A. This so that ACE are in GP. That is C square is equal to A, hence proved. Another example, A to the power X is equal to B to the power Y is equal to C to the power Z, and A, B, C are in GP. Prove that X, Y, Z are in HP. For this solution, A to the power X is equal to B to the power Y is equal to C to the power Z is equal to K, C. If we take A to the power X is equal to K, A to the power X is equal to K to the power 1. This implies A to the power X by X is equal to K to the power 1 by X. दुईटैको पावरलाई X ले डिवाइड गरेको. This implies A is equal to K to the power 1 upon X, equation I. Similarly, if we take B to the power Y is equal to K, then we get B is equal to K to the power 1 upon Y, equation II. Similarly, if we take C to the power Z is equal to K, then C is equal to K to the power 1 upon Z. C is equal to K to the power 1 upon Z. Again, A, B, C are in GP. Then B square is equal to AC. अगाडि हामीले फर्मुला पढेको छ A, B, C GP मा छ भने बीचको त्यो सेकेन्ड टर्मको स्क्वायर इज इक्वल टु प्रोडक्ट अफ फर्स्ट एन्ड थर्ड. Now B, we have B is equal to k to the power 1 upon y. K to the power 1 upon y whole square. Here A is equal to k to the power 1 upon x. Similarly, C is equal to k to the power 1 upon z. Or by law of indices, this is k to the power 2 upon y. Similarly, k to the power 1 upon x plus 1 upon z. Here k and k same, base are same. Therefore, the 2 upon y is equal to 1 upon x plus 1 upon z. Or 2 upon y is equal to taking LCM xz and z plus x. By cross multiplication, we have y is equal to 2xz upon x plus z. This shows that x, y, z are in HP. This shows that x, y, z are in HP root. I have another example, which is a very important question for class 11. The sum of three numbers in AP is 36. When the numbers are increased by 1, 4, 43 respectively, the resulting numbers are in GP. Find the numbers. तीनवटा नम्बर छ एपी मा जसको सम 36 छ र प्रत्येक नम्बरलाई पहिलोलाई 1 ले, सेकेन्ड by 4 and third by 43 increase गर्दा resulting numbers are in GP. Find the numbers. Solution. Let required numbers are A minus D, A and A plus D, because three numbers are in AP. Here A minus D, A and A plus D. A minus D plus D, A plus D, A plus D. प्रत्येक नम्बर पहिलो भन्दा A ले D ले बढिरहेको छ. By the question, the sum is 36. A minus D plus A plus D is equal to 36. Your D cancel. Our 3A is equal to 36. Now dividing both sides by 3, get A is equal to 12. Again, when the numbers are increased by 1, 4, 43 respectively, A minus D is increased by 1, then A minus D plus 1, A is increased by 4, A plus 4, and last one A plus D is increased by 43. A plus D plus 43 are in GP. That is, we have A is equal to 12. 12 plus 1, 13. Minus D. 12 plus 4, 16. And 12 plus D plus 43. 12 plus 43. 55 plus D are in GB. Continue. 13 minus D, 16 and 55 plus D are in GB. Then T2 by T1. 16 divided by 13 minus D is equal to T3 by T2. 55 plus D divided by 16. Or by cross multiplication method, 16 into 16, 256. 13 into 55, 715. 13D plus 13D minus 55D plus, here minus D square, or 256 is equal to 715 minus 13 plus 13 minus 55 minus 42D minus D square, or D square plus 42D, 256 minus 715, which is minus 459, is equal to 0. Here 459 and here is minus and 42. Now we need to find two numbers whose difference is 42 and the product is 459. Or D square plus 51 minus 9. 51 minus 9. 51 minus 9, which is 42. The 51 into 9, 459. D minus 459D. Or D square plus 51D minus 9D minus 459 is equal to 0. Or D common, D plus 51 minus 9, D plus 59 is equal to 0. Or D plus 51 into D minus 9 is equal to 0. Either D plus 51 is equal to 0, then D is minus 51. Or D minus 9 is equal to 0, then D is 9. So therefore, D is minus 51 or 9. Now, when A is 12 and D is 9, required numbers are A minus D, A plus D. That is A minus D. A minus D, this is 3, A 12 and A plus D, which is 21. When A is 12 and D is minus 51, required numbers are similarly A minus D, A plus D. A minus D, A plus D. We have A is 12, D is minus 51. 12 minus 51, that is plus. So that is 12 plus 51, 63. A is 12. A plus D, 12 minus 51, minus 39. Therefore, required numbers are 3, 12, 21 or 63, 12 minus 39. Okay. Now we have another example. If A, B, C are in HP, prove that BC upon B plus C, comma CA upon C plus A, comma AB upon A plus B are in HP. For this solution, by given A, B, C are in HP. Here HP. Therefore, the B is equal to 2AC upon A plus C, or 2AC is equal to AB plus BC. Equation I. Now we need to show BC upon B plus C, CA upon C plus A, AB upon A plus B are in SP. We need to show BC upon B plus C, CA upon C plus A, AB upon A plus B are in HP. That is, middle term CA upon C plus A is equal to the 2 times of first term, the 2 times of BC upon B plus C times AB upon A plus B. The 2 times of first and third divided by first term BC upon B plus C plus AB upon A plus B. तो यहाँ BC upon B plus C, CA upon C plus A, AB upon A plus B लाई HP मा शो गर्नको लागि हामीले यो कन्डिसन देखाउन सक्नु पर्यो, यो रिजल्ट ल्याउन सक्नु पर्यो. Now taking right hand side is 2 times of BC upon B plus C, AB upon A plus B, BC upon B plus C plus AB upon A plus B. This is your B plus C, A plus B is LCM, then 2 times of BC times AB. This is 2AB square C. Similarly, in denominator, B plus C, A plus B, the BC times A plus B plus AB times B plus C. Or this is your, this cancel, then 2A B square C. Here B and B is common, so B times C times A plus B plus B is common, then A times B plus C. Here B again cancel. The 2ABC upon AC plus BC, AB plus AC. This is 2ABC upon AC, 2AC, the BC plus AB. 2ABC upon here 2AC. We have 2AC is equal to AB plus BC. AB plus BC and BC plus AB again. So this is 2ABC upon AB plus AB, 2AB, and BC plus BC, 2BC. Again B is common, so it becomes 2ABC upon B times sorry, 2b is common, a plus c. The 2b cancel, then ac upon a plus c, which is our left hand side. This is our left hand side, hence proved. Now, the finite and infinite series. If the number of terms in a series are finite, then it is said to be finite. Otherwise, it is said to be infinite. Like 2 plus 4 plus 6 plus 8 plus plus 20. Here, number of terms are limited, finite. So, it is finite series. Finite series. Similarly, 5 plus 10 plus 15 plus Here, number of terms in series are infinite, unlimited. So it is called infinite series. Now, sum of an infinite GP. Let GP is A, AR, AR square, Then sum is equal to A times 1 minus R to the power n upon 1 minus R, which is equal to A upon 1 minus R minus A into R to the power n upon 1 minus R when R is less than 1. In this case, as n tends to infinity, R to the power n tends to 0 when modulus of R is less than 1. The R के सब R को modulus less than 1 से suppose 1/2 मानो अथवा 1/3 मानो, तो इसको पावर R को पावर n, तो n लाई हामी टेन्स टु इन्फिनिटी बढी से बढी बढाउँदै जाने भने डिनोमिनेटर बढ्दै जान्छ र R to the power n टेन्स टु 0. जति n हामी बढाउँछौं यसको भ्यालु 0 को नजिकमा जान्छ. Therefore, Sn is equal to here A upon 1 minus R minus 0. As n tends to infinity, modulus of R is less than 1. Therefore, S infinity is equal to A upon 1 minus R. If and only if modulus of R is less than 1. Therefore, sum of an infinite GP. त्यस्तो GP जसको इन्फाइनाइट सिरिज छ GP मा, त्यसको पनि सम हामीले निकाल्न सक्छौं A upon 1 minus R को फर्मुलाबाट. तर त्यसका लागि के हुनु पर्यो? कमन रेशियोको एब्सोल्युट भ्यालु चाहिँ नि अलवेज लेस देन 1 हुनु पर्यो. अदरवाइज सम निकाल्न सकिन्न. Okay, we take one example. 1 plus 1/3 1/3 square plus 1/3 cube plus to infinity. Here T2 by T1 is equal to T3 by T2. So this is GP. And to infinity. So it is infinite geometric series. Infinite geometric series. Here A, first term A is 1, the common ratio R is equal to T2 by T1, which is 1 upon 3 upon 1, which is again 1 upon 3. So here modulus of 1 upon 3, modulus of 1 upon 3, that is modulus of R is less than 1. So it has finite sum. The के बुझ्नु पर्यो यदि common ratio को modulus less than 1 भयो भने यसको finite sum हुन्छ. अब त्यसको लागि हामी sum S infinity is equal to A upon 1 minus R. We have A is 1 upon 1 minus R is 1 upon 3. And this is 1 upon 3 minus 1, 2 by 3. And this is 3 by 2. It's the sum of given series. Okay, we take another example. The sum of an infinite number of terms in GS, that is geometric series, is 15 and the sum of their square is 45. Find the series. Solution: let A be the first term and R be the common ratio. Then series is plus AR square plus dot 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 to infinity. By the question, the sum of an infinite number of terms in GS is 15. A plus AR square plus dot 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 to infinity is 15. Or we have formula for sum of an infinite GP, which is A upon 1 minus R, because here first term is A and common ratio is R. So this is equal to 15, or A is equal to 15 times 1 minus R, equation I. Again, sum of their square, A square R square, A square R to the power 4 plus dot 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 to infinity is 45. अर्को हामीलाई के दिएको छ, सिधा हामीले सम निकाल्यौं, त्यो 15 थियो, त्यसलाई स्क्वायर गरेर सम निकाल्छौं भने 45 हुन्छ. और अगेन फर्मुला A upon 1 minus R is equal to 45. Or we have A is first term. Your first term is A square upon 1 minus R. R is T2 by T1. Like R is T2. We have T2 is A square R square upon T1. A square. The A square cancel. R square is equal to 45. Or A square is equal to 45 times 1 minus R square. We have A is equal to 15 times 1 minus R. 15 times 1 minus R square is equal to 45 1 minus R square. Or this is 15 square, 225 1 minus R whole square, 45 times 1 plus R 1 minus R. Continue. Here R is less than 1. That is modulus of R is less than 1. So 1 minus R is not equal to 0. So cancel out 1 minus R, 1 minus R, and here 15 is common factor. So 15 times, this is 15 times 1 minus r, and this is 3 times 1 plus r. Again 3 to 5. So this is 5 minus 5r is equal to 1 plus r. The 5 minus 1, 4, and r plus 5r, 6r, or r is equal to 4 by 6. This is 2 by 3. Now, by equation I, we have a times, by equation I, a is equal to 15 times 1 minus r. 15, 1, we have r is equal to 2 by 3. 15 into 1 upon 3, so a is 5. Now, the required series is a plus ar plus ar square plus dot, dot. That is, we have a is 5. 5 plus ar, 5 into 2 by 3, 10 upon 3, ar square, ar square, 5 into 4 by 9, 20 by 9 plus dot, 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 is the required series. Okay, we take another example to prove that 3 to the power 1 upon 3, 3 to the power 1 upon 9, and 3 to the power 1 upon 27 to infinity is equal to root 3. Solution. We have 1 upon 3 plus 1 upon 9 plus 1 upon 27 to infinity, which is infinite GS. So we have formula for sum. Here a is equal to 1 upon 3, r is equal to T2 by T1, T2 by T1, the 1 upon 9 upon 1 upon 3, this is 1 upon 3, 1 upon 3. The sum S infinity a upon 1 minus r is 1 upon 3, 1 minus r is 1 upon 3. So this is 1 upon 3 by 2 by 3. 3 cancel, this is 1 upon 2. Now taking left hand side, the left hand side, 3 to the power 1 upon 3, 3 to the power 1 upon 9, 3 to the power 1 upon 27 to infinity. By law of indices, here base are same, then 3 to the power 1 upon 3 plus 1 upon 9 plus 1 upon 27 to infinity. And this is 3 to the power infinite GS, which have sum 1 upon 3, 1 upon 9, 1 upon 27 plus to infinity. यो हामीले अगाडि गरिसकेका छौं, जसको सम 1 upon 2 छ. यसको सम 1 upon 2 छ. 3 to the power 1 upon 2, which is root 3 root. We take another example. Here x is 1 upon 1 plus y and y is positive. to prove that x plus x square plus x cube plus to infinity is equal to 1 upon y. So solution, since y is positive, so x is equal to 1 upon 1 plus y. Here y is positive, so denominator is always greater than 1. So 1 upon greater than 1, the numerator is 1 and denominator is greater than 1. So it is always less than 1. Always less than 1. Because y is positive number. For positive number, 1 upon 1 plus y is less than 1. Now, given series x plus x square plus x cube plus to infinity is equal to, here t2 by t1 is equal to t3 by t2. भनेको t1 लाई t2 ले र t3 लाई t2 ले डिभाइड गर्दा सेम पाउँछौं हामीले रेशियो. त यो हाम्रो इन्फाइनाइट ज्योमेट्रिक सिरिज. And common ratio is x, and first term is again x. Here x is less than y. The modulus of x is again less than y. So it has finite sum. By using formula a upon 1 minus r. A. Your first term is x upon 1 minus r. R is t2 by t1. X square by x gives x. So r is again x. We have x is equal to 1 upon 1 plus y. 1 upon 1 plus y upon 1 minus x is 1 upon 1 plus y. So this is 1 upon 1 plus y. Here 1 plus y into 1, 1 plus y minus 1 upon 1 plus y. Here 1 plus y cancel out, 1 cancel. Then this is 1 upon y, which is right hand side. Proved. Okay. Now the sum of the natural numbers. Since natural number are one, 2, 3, 4, and so on. Now we have to find the sum of the natural numbers. The first sum of first n natural numbers. So let Sn be the sum. Then Sn is equal to 1 plus 2 plus 3 plus 4 plus plus n. Here the 1 plus 2 plus 3 plus 4 plus n, which is AP, because each term is increased by 1 from previous term. So using formula n by 2 2a plus n minus 1 times d. This is n by 2, 2 into the first term a is 1, n minus 1, the common difference d, t2 minus t1, the 2 minus 1, 1, 3 minus 2, 1, the 4 minus 3, 1. So we put d is 1. This is n by 2, 2 plus n minus 1. This is n by 2, n plus 1. On the other hand, alternative method, Sn is equal to n by 2 a plus l. Here n by 2 a. The first term is 1. The last term is n. So this is n times n plus 1 divided by 2. Now the formula for sum of the first n natural number is n times n plus 1 divided by 2. Similarly, we can show that sum of the first n even natural number Sn is n times n plus 1. Sum of the first n even natural number 2 plus 4 plus 6 plus ... Formula is n times n plus 1. B. C. Sum of the first n odd natural number. Formula is n square. Now, sum of the squares of first n natural numbers, which is very important for exam. Sum of the square of first n natural numbers. The derivation is very important for our exam. The let Sn is equal to 1 square, 2 square, 3 square plus ... plus n square. We have n minus 1 whole cube is equal to n cube minus 3n square plus 3n minus 1. The formula whole cube of a minus b, a minus b whole cube, a cube minus 3a square b plus 3ab square minus b cube. This implies n cube minus n minus 1 whole cube is equal to 3n square minus 3n plus 1. तो मैले के गरेँ, सुरुमा a minus b को होल क्यूब को फर्मुला खोलेँ, तो यो क्यूब लाई एकतिर राखेँ, बाँकीलाई एक साइड राखेँ. This is an identity. Which is true for all values of n. Now, sum of the square of first n natural numbers, which is very important for our exam. So, let Sn is equal to 1 square, 2 square, 3 square plus ... plus n square. So we have r minus 1 whole cube. R minus 1 whole cube. The formula of a minus b whole cube. R cube minus 3 a square means r square into 1 plus 3 1 square minus 1 cube. A minus b whole cube, a cube minus 3a square b plus 3ab square minus b cube. This implies r cube minus r minus 1 whole cube is equal to 3r square minus 3r plus 1. तो मैले के गरेँ a minus b को होल क्यूब को फर्मुला खोलेँ त्यसपछि क्यूब क्यूब टर्मलाई एकतिर राखेँ यसलाई उता लगे त्यो बाँकी सबैलाई यता ल्याएँ. This is an identity. So this is true for all values of r. So put r is equal to 1, 2, 3, n respectively. We get 1 cube minus 1 minus 1, 0 is equal to 3 into 1 square, 3 into 1 plus 1. Just r को ठाउँमा 1 राखेको. So similarly 2 राखौं. The 2 cube minus 2 minus 1, 1 cube, 3 into 2 square minus 3 into 2 plus 1. Similarly, if r is 3, then 3 cube minus 2 cube is equal to 3 into 3 square minus 3 into 3 plus 1. To continue, the 4, 5, 6 राख्दै जाने. The last member n राख्छु. N cube minus n minus 1 cube is equal to 3 into n cube minus 3 into n plus 1. Adding vertically, we get here 1 cube minus 1 cube cancel. Similarly, 2 cube minus 2 cube cancel. 3 cube minus 3 cube cancel. Similarly, the n minus 1 cube minus n minus 1 cube cancel. यसले यसलाई कट गरेछ. यसले यसलाई कट गर्छ. यसले डेफिनेटली त्यहाँ अर्कोलाई कट गर्छ. त गर्दै जाँदा यहाँसम्म यसले यसलाई यसले यसलाई यसले यसलाई भने जस्तै यहाँ एउटा कुनै टर्म छ n minus 1 को क्यूब त्यसले यसलाई क्यान्सल गर्छ. The left hand side becomes only n cube. In right hand side, here 3 is common. The 3 times of 1 square, 2 square, 3 square, plus n square. Similarly, the minus 3 is again common. The 1 plus 2 plus 3 plus plus n plus the 1 plus 1 plus 1 plus 2 n terms. N terms. Because sum of first n square of first n natural numbers. We need to find sum of first n natural numbers. So we take 2 n terms or n cube 3. This is Sn minus 3. This is sum of first n natural numbers, which is n times n plus 1 divided by 2 and 1 plus 1 plus 1 plus 2 n times or n terms. If we take 1 3 times, then sum is 3. If we take 1 5 times, then sum is 5. Similarly, if we take 1 n times, then sum is n. यहाँ एकचोटि फेरि क्लियर हो त 1 लाई 3 तीनवटा 1 लियो भने सम 3 हुन्छ, 10 वटा लिए 1 सम 10 हुन्छ। त म लिदैछु n टर्म्स, n वटा लिदैछु सम n भयो। और n क्यूब प्लस 3n times n plus 1 divided by 2 minus n is equal to 3sn. सबैलाई यता ल्याए। Here n is common, then n square plus 3 times of n plus 1 divided by 2 minus 1 is equal to 3sn. Or n, here LCM is 2, so 2n square plus 3n plus 3 minus 2, 3sn. Continue. 3sn is equal to n by 2, 2n square plus 3n plus 1 is equal to n by 2. The 2n square here, 2 into 1, 2. Here is plus 3. We need to find two numbers. So sum is 3 and product is 2. So 3n is 2n plus n plus 1. N by 2. 2n common. N plus 1 from this side. 1 is common. N plus 1. N plus 1 is common. 2n plus 1. 1 divided by 2. So therefore, Sn is n times n plus 1, 2n plus 1 divided by 6, which is the formula for sum of first square of first n natural numbers. Sn is equal to n times n plus 1, 2n plus 1 divided by 6. Okay, similarly, can prove that sum of cubes of first n natural numbers, Sn is equal to 1 cube, 2 cube, 3 cube plus plus n cube, and its result is n square n plus 1 whole square divided by 4. जसरी मैले स्क्वायर को केसमा काम गरे थिए, क्यूब को केसमा पनि यसरी नै बनाउन सकिन्छ. Now notes. One, summation n. The n run from 1 to n. 1 plus 2 plus 3 plus plus n. The sum of first n natural number, which is equal to n times n plus 1 divided by 2. This is very important. Similarly, summation n square, and run from again 1 to n. 1 square, 2 square, 3 square, n square, and its formula is n plus 1, 2n plus 1 divided by 6. Similarly, summation n cube, the 1 cube, 2 cube, 3 cube plus n cube. This is n square, n plus 1 whole square divided by 4. Very simple. Square up this n square, n plus 1 whole square, 2 square. Continue. 4 summation 1. The 1 plus 1 plus 1 plus 2 n times to n terms, which is n. Okay, here is another series, arithmetic series. If we take two arithmetic series like A1, A2, A3, AN, and B1, B2, B3, Bn, then A1, B1, A2, B2, A3, B3 plus which is arithmetic series. त पहिला मैले एउटा एपी लिए, another एपी लिन्छु. त फर्स्ट टर्मलाई फर्स्टले, सेकेन्डले अनि करेस्पोन्डिङ टर्मले मल्टिप्लाई गरेर अथवा डिभाइड पनि बनाउन सक्छौँ, तर इन जनरल हामी मल्टिप्लाई गर्छौँ. त यो खालको सिरिज हाम्रो हुन्छ अर्थमेटिक सिरिज, AA सिरिज. योसँग रिलेटेड क्वेसन एक्जाममा बढी सोध्छ. हामी त्यसको केही एक्जाम्पल. ओके, we have an example. Find the nth term and sum of the first n terms of the series 1 plus 4 plus 9 plus 16. Solution: given series is 1 plus 4, 9, 16. Here the 4 minus 1 is 3. So 9 minus 4 is 5. Since differences are different, so it is not AP. Similarly, T2 by T1, that is 4 by 1, is not equal to T3 by T2, 9 by 4. यो AP पनि होइन, GP पनि होइन. तब यसलाई हामी 1 square, 2 square, 3 square, 4 square यसरी राख्न सक्छौँ. Now, except square, if we take 1, 2, 3, 4, then it forms AP. यसले AP बन्छ. So, nth term of 1, 2, 3, 4 is A plus n minus 1 times D, because it's AP. But our given series is 1 square, 2 square, 3 square, 4 square. So here 1 square, 2 square, 3 square, 4 square, then it's whole square. यहाँ स्क्वायर छ, सरी स्क्वायर छ, सो मैले स्क्वायर राखेँ. यदि पावर क्यूब थियो मैले क्यूब लिन्थेँ. So this is A. Here A is 1 and minus 1, the D. 2 minus 1, 3 minus 2, 4 minus 3. प्रत्येकमा 1 छ. Square. So 1 plus n minus 1 square, 1 cancel. This is n square. Therefore, Tn is n square. if we put n is 1, then it gives 1 square is 1, first term. Similarly, if we put n is 2, then 2 square, which is 4. Similarly, if we put n is equal to 3, then 3 square, which is 9. And similarly, if we put n is equal to 4, then 4 square, which is 16. So, our Tn, which is n square, is correct. For next part, sum. Let Sn be the sum of first n terms, then Sn is equal to summation Tn, the general term. Summation, here Tn is n square. And n run from 1 to n. The 1 square, 2 square, 3 square plus n square. We have formula for squares of first n natural numbers, which is n plus 1, 2n plus 1 divided by 6 is the answer. Take another example. 2 plus 6 plus 12 plus 20 plus dot dot dot. We need to find general term Tn and sum of first n terms. For this, the given series is 2 plus 6 plus 12 plus 20 plus dot dot. That is 1 into 2, 2 into 3, 3 into 4, 4 into 5 plus dot dot. Here, if we take 1, 2, 3, 4, then it becomes AP. So, nth term of 1, 2, 3, 4 dot 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 is again formula A plus n minus 1 times D, which is 1 plus n minus 1 times D. Our common difference, the 2 minus 1, 3 minus 2, 4 minus 3, always 1. So this is n. Similarly, nth term of 2, 3, 4, 5. 2, 3, 4, 5 is, again we have formula A plus n minus 1 times D, but our A is 2 plus n minus 1, and common difference is again same, 3 minus 2, which is 1. So it becomes 2 plus n minus 1, which is n plus 1. So therefore, nth term of given series is Tn, which is n into n plus 1, which is n square plus n. For some part, let Sn be the sum of first n terms, then sum Sn is equal to sigma summation Tn. Summation, we have Tn is n square plus n. The summation n square summation n. Here and run from 1 to n. So we put 1 square, 2 square, 3 square plus n square plus again n run from 1 to n. 1 plus 2 plus 3 plus dot 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 plus n. We have formula of square of first n natural number. n plus 1, 2n plus 1 divided by 6 plus sum of first n natural numbers. We have formula n plus 1 divided by 2. Here n plus 1 divided by 2 is common, then n plus 1 divided by 2 is common, then 2n plus 1 divided by 3 plus 1 plus 1. This is n plus 1 divided by 2. Here 2n plus 1 plus 3 into 1, 3 divided by 3. This is n plus 1 divided by 2, 2n plus 4 divided by 3. 2 is common, n plus 1, 2 is common, n plus 2 divided by 2 into 3, here 2 to cancel. And finally, sum of first n terms, Sn is equal to n plus 1 into n plus 2 divided by 3, which is. Now, we have same example, 2 plus 6 plus 12 plus 20 plus dot dot dot. We have alternative method for this question. So, let Tn be the nth term and Sn be the sum of first n terms. Then Sn is equal to 2 plus 6 plus 12 plus 20 plus dot 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 plus T n minus 1 plus Tn question I. त हामीले अघिकै एक्जाम्पललाई अर्को मेथडले हेरिरहेछौँ र मैले nth टर्म Tn यानी कि जनरल टर्म Tn सपोज गरे र सम Sn. The sum Sn is T1 plus T2 plus T3 plus Tn. And again Sn is 2 plus 6 plus 12 plus plus Tn minus 1 plus Tn. इक्वेसन आयो. त के गरे सेम इक्वेसन आइलाई आई बनाए कपी गरे तर एक स्टेप पछाडिबाट. Here the 6 minus 2 4, 12 minus 6 6. The differences are different. So this is not AP. So similarly T2 by T1 र T3 by T2 गर्दा पनि रेशियो डिफरेन्ट हुन्छ. त्यसकारण यो जीपी पनि होइन. अब यो खालको प्रब्लमलाई हामीले Tn कसरी निकाल्ने? अघि नै एउटा मेथड हेर्यौं. अब अर्को मेथडको लागि सुरुमा इक्वेसन 1 त्यही इक्वेसनलाई कपी गरे तर एक स्टेप ब्याकबाट. Now I minus II. We get subtracting II from I. Sn minus Sn 0 2 6 minus 2 4 12 minus 6 6. The 20 minus 12, 8 plus Tn minus 1. Last minus Tn. मैले कसरी माइनस गरिरहेको छु 6 minus 2, 12 minus 6, 20 minus 12, Tn minus 1. Last step बच्यो, so minus Tn. त्यो minus Tn लाई यता ल्याऊ. Tn is 2 plus 4 plus 6 plus 8 plus ... 2 n terms. अब यहाँनिर कन्फ्युजन हुन्छ. Tn यता आयो. 2 4 6 8 ... 2 n terms. Because Tn be the nth term and Sn be the sum of first n terms. हामीले कति ल्याएको छ n वटा छ. सो यो एक स्टेप ब्याक भए पनि त्यसलाई अगाडि ल्याउँदा 2 n terms. यो कहाँ गयो? यो भनेको n terms होइन. यो कहाँ गयो हराउँयो भन्दा पनि अगाडि देखि काउन्ट गर्ने भने n वटा टर्म्स हुन्छ. कन्फ्युजन छ भने मैले अहिले एउटा एक्जाम्पल दिएर देखाउँछु. नाउ कन्टिन्यू. Tn is the 2 plus 4 plus 6 plus 8 plus ... 2 n terms, which is AP. हाम्रो टार्गेट नै यही थियो ताकि त्यो AP र GP नभएको क्वेशनलाई AP बनाउनु हो. AP को सम को फर्मुला n/2 2a plus n minus 1 times d. Here n/2 2 into a. The first term is 2. n minus 1. The d, common difference. 4 minus 2, 2. 6 minus 4, 2. 8 minus 6, 2. n/2. The 4 plus 2n minus 2. n/2. 2n plus 2. n/2, 2 is common, n plus 1, 2 to cancel. So Tn is n square plus n. In both method, we have Tn is n square plus n. If we put n is equal to 1, then it gives 1 square plus 1, which is 2, which is our first term. Similarly, if we put n is equal to 2, the 2 square plus 2, which is 6, which is our second term. And if we put n is equal to 3, the 3 square plus 3, which is 12, which is our third term. So our Tn is 100% correct. Okay. If we take 5 numbers, Sn, S is equal to A plus B plus C plus D plus E. S is sum of 5 numbers A plus B plus C plus D plus E, which is equation I. Again, S can be written as A plus B plus C plus D plus E, equation II. Now, I minus II. We get S minus S, 0, A, the B minus A, B minus A, C minus B, similarly, D minus C, E minus D, minus E. Now we have 6 terms, 1, 2, 3, 4, 5, 6. But in equation 1, we have only 5 terms, 1, 2, 3, 4, 5. Similarly, in second equation, 1, 2, 3, 4, 5. के थियो सुरुमा 5 वटा लिए यसलाई यो तरिकाले राख्दा I minus II गरे त मसँग कतिवटा हुँदो रहेछ 6 वटा हुँदो रहेछ. Finally, the minus E is equal to a plus b minus a, c minus b, d minus c plus e minus d. Or it can be written as b minus a plus c minus b plus dot dot dot. We have 1, 2, 3, 4, 5. 2, 5 terms. तो यहाँ एउटा कुरा स्टुडेन्टलाई यो प्रब्लम हुन्छ इच एन्ड एभ्री टाइम अघि नै मैले त्यो माइनस टिएन यता ल्याइसकेपछि 2n टर्म्स कसरी भयो मैले 5 वटा ल्याथे लास्टको माइनसलाई अगाडि ल्याए त्यो मेरो टिएन थियो अब काउन्ट गर्छु भने मसँग 5 वटा छ सिमिलरली मैले यदि अगाडि 10 ल्याथे भने यहाँ 11 वटा हुन्थ्यो र यसलाई अगाडि ल्याइसकेपछि मसँग 10 वटा टर्म्स बाँकी रहन्थ्यो एकचोटी आफैले पनि देखेर हेर्नु ओके वी हेभ अनदर एक्जाम्पल the 1 plus 5 plus 11 plus 19 plus dot, dot, dot. We need to find its general term Tn and sum of first n terms. But given series, here 5 minus 1, which is 4, 11 minus 5, 6, 19 minus 11, 8. Differences are different, so it is not AP. Similarly, 5 upon 1 is not equal to 11 upon 5. Ratios are different, so which is not GP. Now, its solution. Let Tn be the nth term and Sn be the sum of first n terms. Then Sn is equal to 1 plus 5 plus 11 plus 19 plus Tn minus 1 Tn equation I. First term, second, third, fourth, the last term and second last term, the previous term. Equation 1 can be written as 1, 5, 11 plus Tn minus 1 plus Tn II. अगाडि एक्जाम्पलबाट क्लियर गरेको थिए एक स्टेप ब्याक गरेर नाउ I minus II we get this is 0 1 here 5 minus 1 4 11 minus 5 6 19 minus 11 8 finally Tn minus Tn minus 1 minus Tn. Now minus Tn is equal to 1 plus 4 plus 6 plus 8 plus 2 n terms. Here 4 minus 1 3 6 minus 4 2 8 minus 6 2 यहाँ 1 नहुने हो भने यो एपी बन्छ फर्स्ट टर्मलाई हटाइदिने भने एपी बन्छ सो दिस इज 1 plus 4 plus 6 plus 8 plus 2 n minus 1 terms. अब यसमा अलिकति क्लियर हुने n थियो n minus 1 किन भयो धेरै स्टुडेन्टहरुको सवाल धेरैलाई प्रब्लम अगाडि सिधै एपी भएन हाम्रो टार्गेट थियो एपी बनाउने त मैले यहाँ फर्स्ट टर्म छोडी एउटा टर्म छोडी सो n minus 1 इन केस मैले 1 र 4 दुईटा छोड्थे n minus 2. Similarly, and so on. Now, you complete our APs. Continue. Tn is equal to 1 plus formula sum for AP. N by 2, 2a plus n minus 1 times d. 1 plus n. This is n minus 1. Divide by 2. A. 4. N. We have n is n minus 1. Minus 1. N is n minus 1. The d. The 6 minus 4. 8 minus 6. 2. 1 plus n minus 1 divided by 2. Here 2 is common. Then 4 plus n minus 2. 2 to cancel. The 1 plus n minus 1. N plus 2. 1 plus n square plus 2n minus n minus 2. The final answer, n square plus n minus 1. If we put n is 1, then 1 square plus 1 minus 1, which is 1, which is our first term. Similarly, if we put 2, n is equal to 2, then 2 square plus 2 minus 1, which is 5, which is our second term. Similarly, if we put n is equal to 3, 3 square plus 3 minus 1, which is 11, which is our third term. So धेरै जस्तो स्टुडेन्टले के गर्छ, आफूले बिग्रिएको पत्तै पाइन्न. सो n को ठाउँमा 1 2 3 राखेर चेक गर्दा फर्स्ट टर्म, सेकेन्ड टर्म, थर्ड टर्म मिल्यो मिलेन त्यसलाई ख्याल राख्ने. नाउ फर सम पार्ट, नाउ सम Sn is sigma Tn. Sigma Tn is n square plus n minus 1. The sigma n square, sigma n minus sigma 1. Your n run from 1 to n. So you put 1 square plus 2 square plus 3 square plus plus n square, which is sum of square of first n natural number. We have formula n plus 1, 2n plus 1 divided by 6. Similarly, if we put n is 1 plus 2 plus 3, we have formula for sum of first n natural number, n plus 1 divided by 2 minus sum of 1 to n terms. If we take 3 1, then sum is 3. If we take 5 1, then sum is 5. If we take n 1, then sum is n. 5 वटा 1 ले sum 5 हुन्छ, n वटा ले n हुन्छ. Now here n is common. n plus 1, 2n plus 1 plus n plus 1 divided by 2 divided by 6 minus 1. Now LCM is 6. The 2n square plus n plus 2n plus 1, 2, 6 divided by 2, 3 times of 3n plus 3 minus 6. And this is n, 2n square n plus 2n plus 3n plus 6n. 1 plus 3, 4 minus 6, minus 2 divided by 6. And this is n. Here 2 is common. N square plus 3n minus 1 divided by 6. 2, 3. So n times n square plus 3n minus 1 divided by 3 is the answer. Okay, we have another example, which is very important question. Find general term and sum of first n terms 1 into n plus 2 into n minus 1 plus 3 into n minus 2 plus dot dot dot. So solution: given series is 1 into n plus 2 into n minus 1 plus 3 into n minus 2 plus dot dot dot. If we take the 1, 2, 3, which form AP. Similarly, n minus 1, n minus 2 every variable AP दिन्छ. त्यसपछि यो arithmetic AA series, which is AA series. Nth term of 1, 2, 3, dot, dot, dot. The 1, 2, 3 is A plus R minus 1 times D. Here R star, because here n is already used, so rth term is A plus R minus 1 times D. This is A is 1, R minus 1 into D is again 1. Common difference is 1. This is 1 plus R minus 1, just R. Similarly, rth term of n minus 1, n minus 2. n minus 2, n minus 1, n minus 2, and so on. Is again formula A plus R minus 1 times D, because here rth term. So we have A is, first term is n plus R minus 1, into common difference T2 minus T1 or T3 minus T2 minus 1. This is n minus R plus 1, which is n plus 1 minus R. Therefore, rth term of given series is TR, which is R times n plus 1 minus R, which is n plus 1 times R minus R square. Let Sn be the sum of first n terms, then Sn is equal to sigma TR. because our general term is tr. We need to find sum of first n terms. So we write Sn is equal to sigma general term tr. This is n plus 1 times r minus r square. This is n plus 1 sigma r minus sigma r square. Here r run from 1 to n. Similarly, r run from 1 to n. Then we have formula of sum of first n natural numbers. Formula of sum of first n natural numbers, which is n times n plus 1 divided by 2. Similarly, formula of sum of squares of first n natural numbers, because r run from 1 to n. If we put r is equal to 1, 2, 3, up to n, then we have 1 square plus 2 square plus 3 square plus plus n square. So this is n plus 1 2n plus 1 divided by 6. And this is here n plus 1 and n is common. n plus 1 divided by 2 is common. Here n plus 1 minus 2n plus 1 divided by 3. Continue. This is n plus 1 by 2. And here LCM is 3. 3n plus 3 minus 2n minus 1. n plus 1, 3n minus 2n, n plus 2 divided by 6, which is the answer. We have another example, sum to n terms of the series. Similar way, you can find the sum of first n terms of given series. For this, first we have to find its general term Tn and a term. So solution, given series is 1 cube, 3 cube, 5 cube plus . Here nth term of 1, 3, 5 is a plus n minus 1 times d, because which is ap 1, 3, 5. And this is a is 1, n minus 1, and d is 2. Your common difference is 2. 3 minus 1, 5 minus 3, 2. 1 plus 2n minus 2. So this is 2n minus 1. But in question, here power 3. So nth term of 1 cube, 3 cube, 5 cube is whole cube. Whole cube. Whole cube. Whole cube. The power में square थियो, square use गर्ने, cube छ, cube use गर्ने. Now formula of a minus b whole cube, a cube, 2n cube, a cube minus 3a square b plus 3a b square minus b cube. A cube minus 3a square b plus 3a b square minus b cube. So this is 8n cube minus 2 square 4 into 3 12 n square plus 6n minus 1. Now for next part, perform. Let Sn be the sum of first n terms, then Sn is sigma Tn. Summation, we have Tn 8n cube minus 12n square plus 6n minus 1. This is 8 times of sigma n cube minus 12 times of sigma n square plus 6 times of sigma n minus sigma 1. And here 8 sum of cubes of first n natural number, which is n square n plus 1 whole square divided by 4 minus 12 sum of square of first n natural numbers. Formula: n plus 1 2n plus 1 divided by 6 plus 6 sum of first n natural numbers, n plus 1 divided by 2 minus n, because summation 1 is always n, because here is Sn. 2 and into here n is common, then 2n n plus 1 whole square minus 2 n plus 1 2n plus 3 n plus 1 minus 1, because n is common. Continue. This is n. 2n n square plus 2n plus 1 minus 2 by multiplying n plus 1 into 2n plus 1, 2n square plus n plus 2n plus 1 plus 3n plus 3 minus 1. And this is n times 2n cube plus 4n square plus 2n minus 4n square minus 2n minus 4n minus 2 plus 3n plus 2. 3 minus 1, 2. Here 4n square minus 4n square cancel, plus 2n minus 2n can cancel, and n 2n cube minus 4n and then minus 2 plus 2 cancel, the minus 4n plus 3n minus n. N is common, then n square, 2n square minus 1, which is the answer.